The laws of sines and cosines. What are these? They're mathematical equations, more specifically trig functions, that solve for a side or an angle in a non-right triangle, so any triangle without a right angle. Now, what do these equations look like? As you can see, the law of sine is a over sine A equals b over sine B equals c over sine C. Now, it's only two of these. They're interchangeable, so a over sine A equals b over sine B, and a over sine A could equal c over sine C. And the cosine one, law of cosine, is c squared equals a squared plus b squared minus 2 multiplied by a and b, and then the cosine of whatever angle you're looking for. Sometimes you're given one, but I'll show you that in the examples. These are also interchangeable. So, for example, it could be a squared equals b squared plus c squared minus 2 times b times c cosine of whatever angle. And then you can flip it around however you want. But who even made these? So, please cut me some slack. These are names, alright. Regiomontanus, old German mathematic, made the law of sines in 1464. I believe he published a book about it, or it was a study. And then we're just going to call him Al-Kashi because Jamshid Al-Kashi, I'm guessing, made the law of cosines in the 15th century, just sometime, and like I said, they are trigonomic functions, trigonometry functions, trigonomic functions, however you want to say it. Let's look at some examples. The law of sines. So, like I said, the law of sine equation is a equals sine A, or a over sine A equals b over sine B equals c over sine C. And these are some applications, just some example problems. So, for example, you have 16 over sine 36 with a lowercase b over sine 17. Now, how do you go about setting this up? Okay, so you do this thing called cross multiplying, which, just zoom in a little bit, means you put an X looking thing, and you cross multiply it. What's this going to look like worked out? Okay, so you're going to get 16 sine 17 equals b sine 76. Then you divide both sides by, or that's sine 36. I'm sorry, that looks confusing. It's sine 36, yeah. And you divide both sides by your sine 36. Those two cancel out, so then you end up getting this fraction. That's going to equal b. The answer, I ran all these through Desmos. This was ran through the Desmos app, checked. I was in degrees mode, do not worry. 7.9, or 7.90 something, but 7.9 is the much more simple answer. So, I mean, this is the worked out version, and we have another example. Let's check that one out. This time, you have sine capital B, and you have a value in the lowercase b spot. So what do you have? You have 16 over sine 36 equals 12 over sine B. And how do you go about setting those up? You cross multiply again. I just didn't work this one out. Well, I worked this one out fully, actually. So you have 12 sine 36 equals 16 sine B. You divide both sides by 16. The 16s cancel out. You're going to get 0.440 something. And then you're going to inverse sine. Now, since this is a decimal below 1, it can be inverse sine. Fun fact, 1 can also be inverse sine. It's 90. Just thought that's something I'll tell you. And its inverse sine is going to be 26.1. So 26.1 is going to equal the sine of B. Now, let's look at some examples of the cosines. Okay? So this tells us to find A through B, which is going to be little c. To explain, every angle has a little letter that matches to it, and it's whatever's across from it. So A, right here, this is little a, or lowercase a, but big and little is what teacher usually says, so you know. Capital B, little b. Capital C, little c, right here. Okay, so finding A through B means we're finding little c. How do we go about that? So here's our values we are given. We're given lowercase a equals 29, lowercase b equals 13. That's the answer. Disregard that. You're not going to get that, but and then your uppercase C is going to equal 41 degrees. So you use the law of cosines. Now, since you're missing little c, you're going to put little c right there. That's the side you're looking for. And then you're going to put little a and little b, which happens to be 29 squared plus 13 squared. Subtract 2, multiply by the same, so I remember it. And then cosine of your angle, which is 41 in this case. And it's going to come out to 440.9 something. I don't remember the full things. I just put about one decimal place. Then, once you're doing something like this, where you have the side, you're finding the side, you're going to take the square root of your result, which happens to be 20.9. 20.9 is your answer to find little c. Next example, we'll go a little bit faster through these. This is asking us to find the measure of angle A, so this, right here. How do we go about that? Well, first you have to use the law of cosines, which you're not originally given C. You're originally given these three values, 29, 28, 52. Now, when you're ever given an A, B, and a C, only an A, B, and C, you have to use the law of cosines first. No negotiation, you can't do anything else. So, like I said, same setup, you're finding the same side, so it's very close. You both, so it's C squared equals 29 squared plus 28 squared minus 2 multiplied by the same cosine of your angle. And that's going to get you to 625.1 something. I don't remember. Like I said, I don't remember the whole number. I go only one or two decimal places. You're going to find the square root of this, which is 25 even. And then 25 even is going to be your little c. But we're finding the measure of angle A. This angle right here. And what you got to do is you got to apply the law of sines. So like I said, set it up. It's going to be, you have these two originally, so use them. So 25 over sine 52 equals 29 over sine A. Cross multiply. You're going to end up through the whole worked out version if you have to. But what I do is just take these, which are going to end up on the top. That's going to end up on the bottom because it's going to be on the side of sine A. So you're going to end up with 29 sine 52 over 25. I apologize for the flickering. My big lights are not the best. So this, which is going to come out to 0.914 something. And then below 1, so you're going to take, or not because it's below 1. That's how you mainly indicate it, but it says because you're looking for the measure of an angle. If you're looking for the measure of an angle, you always inverse sine or inverse cosine or inverse whatever function you're using. That's what will come out to 66. It was like 66.06 something, but since 0 was the first decimal place over, we just come out to 66. Final example, doing everything. Get in focus. Okay, doing everything. Solve the triangle. These are your values, which ones you were originally given. You're originally given all the sides, so all the lowercase letters. So there's your law of cosines, which is going to be 39 squared equals 50, squared plus 64 squared minus 2, multiply the same. Here's something cool. We're looking for angle A to start with. But Desmos, the app, which is the calculator I ran it through, works with X. So put X, but label which one you're finding, which is going to get you to 792 something, which you're going to inverse cosine because you're looking for an angle. That's going to give you 37.6. Put that down right there. Now you're going to use the law of sines, which is 39 over sine 37.6 equals 50 over sine B. And I'll come out to this, which is 50 sine 37.6 over 39, which is going to get you 0.782 something, 0.782 something, whatever you want to say. And since you're looking for an angle, which is always the uppercase letters, you're going to inverse function, which is sine, which is going to get you 51.4 something. Now, you don't want to do all that again. I don't want to do all that again. So, since you have both of your big angles, both A and B, you can use the angle addition postulate, which is this. So, 37.6 plus 51.4 equals 89. Then you take that result, subtract it from 180, 91. That's how you solve the problem. That was the laws of sines, cosines, quick and easy.